what we're doing is we're coming up with the equations and identifying whether the table is linear, quadratic, or exponential. You may want to jot these notes down. Linear equations, and you will have to know this, the notes that are on the board won't be there tomorrow, so make sure you remember that linear equations look like that. Exponential equations have this general type of form. And quadratic equations have this general form. Now, for coming up with the equations, quadratics can be really tricky, and I will give you this tip that you can use for this test, the simpler version, y equals ax squared. Any that I ask you to write will fit that form. Okay? So to decide which one it is, you're going to look at the pattern in the table. So for number 5 here, I might start by looking at the differences. From 4 to 6, that's an increase of 2. From 6 to 9, that's an increase of 3. I'm getting these differences by subtracting. This is an increase of 4.5. So right away, since those aren't the same, I've eliminated the chance of this being linear. Since I've got that, I might look at the second level of differences. This is 1 more, this is 1.5 more. Since those are not the same, I've ruled out quadratic. So it must be either exponential or none, right? If it's exponential, there is a common ratio. And to get a common ratio, what you can do is you can divide. 6 divide 4, which reduces to 3 halves, or 1.5. And you'd want to see if that's the same as 9 divided by 6, which it is. 13.5 divided by 9. If you did 4 divided by 2 2/3, you'd get that as well. So that's the common pattern here. You're multiplying by 1.5, or 3 halves. Since it's the same multiplier each time, this is going to be exponential. And to come up with the equation, we're using this one. The b is the multiplier, 3 halves. The a is the y-intercept, which you can find by looking for the 0 in the table. So the y-intercept is 4. All right? If you look at the next one, number 6, this time I can readily see the pattern is that we're dividing by 3 each time. 18 divided 3 is 6. 6 divided 3 is 2. 2 divided 3 is 2/3. But I like to think of it as multiplying by 1/3. Dividing by 3 is the same as multiplying by 1/3. So it's the same ratio, so it's exponential. This time, the b value is 1/3. And the a is -2. All right? For number 7, as I look at this table, I might start by looking at the changes. This is 1.5 less. This is a half less. This is a half more. This is 1.5 more. So I've ruled out it's not linear. If I look at the second level of differences, this is 1 more, 1 more, 1 more. Those are the same. So that tells me it is quadratic. Now there's a couple ways to come up with the equation. I told you it's going to fit this general form, ax squared. So your job is to find a. One way to find a is just to pick a point. Like, actually this is probably the easiest one to pick. This is my x, this is my y. So if I put 1/2 for y and 1 for x, I get this equation. A half equals a times 1. Which tells us that a is 1/2. Basically, if you have the value for 1 in the table, that value is going to be the a. You could also have likened it or compared it to the parent function, which is just x squared. Remember, that one looks like this. 4, 1, 0, 1, 4. And if I compare these numbers, 4, 1, 0, 1, 4, to these numbers, 2, a half, 0, a half, 2, I notice that all of these are half of the 4, 1, 0, 1, 4. So what I do to the x squareds to get these numbers is I take them, multiply them by a half. All right? So remember, for the quadratic, it's just going to be a matter of finding the a. You won't have a bx plus c to contend with. Number 8. So I'm looking at this one. Now, one thing that may be helpful here is if you want, you can change these so they're all decimals, or you could change them so they're all fractions. I'm going to change this to negative 18/9. And then this would be, or excuse me, negative 18 halves. This would be negative 12 halves. This would be negative 6 halves. So I can now see that if I look at the numerator increases by 3 each time. The denominator stays at 2. So there's a constant pattern here of adding 3 halves. If you had changed them to decimals, you might have seen that as well. This is 1.5 more each time. Well, guess what? 1.5 is equivalent to 3 halves. So I see a constant change, so I know it's linear. That rate of change that's constant is my slope, and then I can see my y-intercept is negative 6. I would also accept the decimal answer here as well. All right? The next group are just a matter of identifying which one matches the correct equation. Number 9, you're just looking for the one that could be written in this form. These 3 can't. This one because an x is in the denominator, this one because the x has the power of 1/4, and D because the x is in the denominator. This one I could distribute the divide 4 and rewrite it like that. So that is a linear function. Number 10 is in mx plus b form. So that is a linear function. Number 11 is in a times b to the power of x form. So that is exponential. And number 12 has an x squared in it. So that tells me it's quadratic. So that's just equation recognition. Okay? And then the final one, number 13, the thing that's tricky about this last one is they're in ordered pairs, so what I would probably do is change it to a table. And when you do that, you see that they made a jump here. They skipped the 2 and went right here. And they skipped the 4. So keep that in mind when you're looking for the pattern. I can see when I make it like this that the pattern here is times 4. Now I don't see that times 4 here because I skipped something. If I wanted to put it in, I could figure it out that it'd be negative 32, and then negative 32 times 4 would be that. And that pattern would hold as well. If you multiplied by 4 2 more times, you get there. So this is exponential, where the a value, the y-intercept is negative 2, and the b value is 4.